Hello and welcome to this video. And this is for video for the final exam for the General Physics 1 lab. So in this video we're going to know how to take the readings of a one-year caliper and screw gauge for different problems, and we're going to see how we can take the readings. For example, this is 1 year caliper and this is your main scale, and this is your 1 year scale. So if the 1 year caliper is given either in millimeter or in centimeter, so we can measure the length in millimeter in this video. So we're going to start by taking the reading. So the least count of vernier caliper is equals to 0.01 millimeter. Okay, so if you see this, and we're going to start from here, and we say that the zero error in this vernier caliper is, we suppose that is 0 millimeter, 0.0 millimeter. So both the main scale and vernier scale reading matches exactly on the same line. So if you see this and you start from here, starting reading, this is 10, then we have 20, and then we have 21, 22, 23, 24 and 25. So see this is 25. So from the total divisions, the small lines we are calculating is 25. So 25 divisions on the main scale. Now we're going to see on the 1 year scale, which is this, and going to see that which line or which divisions are exactly matching. So we're going to start from there. There are 5 divisions in between 0 and 1, 5 divisions between 0 and 2, and 5 divisions. So we take this, for example, 5. So this line is exactly matching in our case, so it's 5 division. So plus 5 divisions multiply by the least count, which is 0.01. so when you multiply 5 multiplied by 0.01 plus 25, so you will get a reading 25.05 millimeter in that case. Let's try another question. So if you see this from here to here, how many divisions? 1, 2, 3, 4, 5, 6, 7. So it's 7 divisions. Then which reading is exactly matching on the 1 year scale, on this scale, is matching with this number, and we count it. Let's suppose, okay, the exactly matching line on this 1 year scale, like on this 1 year scale. So we see that I think this line is matching exactly. So this line is matching exactly. So this line. So we have, then we have 5 divisions, and then we have 10 divisions. So plus 10 divisions multiply by 0.01, and so you will get 10 multiplied by 0.01 plus 7. So your reading is now 7.10 millimeter. and you can try this question for your practice. Now we are moving to the screw gauge. So screw gauge or micrometer. So here is your circular scale, and this is your circular scale, and this is your main scale. Okay, then so on the circular scale there are 100 divisions. On main scale it should be 1 to 10, so 10 division. So if you see this is 0, this is 0 point, this is 0, 0 0.5, 1, and this is 2. So you need to count this. So this least count for the 1 year screw gauge or micrometer is 0.001 millimeter. So you have to select. So if you see this part, so we are here 0, 0, this is 0.5, this is 1, and this is 2 and 2.5. It means the circular scale goes to 2.5 further, plus which divisions on the circular scale on this scale is exactly matching with this line, which is this line. So we need to see, if you see this line is exactly matching. So it's 35, after this 35, 36, 37 and 38. So 38th line is exactly matching, multiply by 0.001, its least count. So 2.5 plus 38 multiplied by 0.001, so you will get 0.038, and then you add, which is 0.538 or 0.54 millimeter. So if you see, so this example done. So now if you see this, so this is 5 gone, then 5.5, then 6 and 6.5. So in that case 6.5, and which reading is exactly matching this reading? This line is exactly matching with this line. So it's 15, 16, 17 and 18. So 18 multiplied by 0.01. And the same for this. For example, this is 2, this is 2.5, 3, 3.5, so it's gone to 3.5. Which line exactly matching? This line. So 30, 31, so plus 31 multiplied by 0.001. Over here is 0.01. Okay, so you can calculate. And same goes for this. For if you see this example, so this is 0, this is 1, 2, 3, so it gone past 3. Then which line is exactly matching? This line is exactly matching. So 5, 6, 7, 8, 9. So 9 multiplied by 0.001, so you can calculate. The same goes for this reading. So you have only 0 gone, and which line is exactly matching? I think this one, we suppose that. So after 25, 26, 27, 28, 29, so 29 multiplied by 0, sorry, so 0 plus 29 multiplied by 0.001. So when you do this calculation. So you can try these two examples for your practice. Now let's move to an example. So if you see this diagram, the diagram below shows an enlargement of the scale on the micrometer screw gauge when taking the measurement. So we are taking some measurement and the diameter of the cylinder metal rod is measured. So diameter is measured using the micrometer. So if you say this is 2, 2.5, 3, 3.5. So the first reading goes 3.5 plus which division is exactly matching with this line. So it's 31 multiplied by 0.01. So you will get 3.81 millimeter. So this is the diameter measurement of this cylindrical metal rod, but what is asked is to calculate the cross sectional area. So cross sectional area is the formula pi r squared. So pi r squared. So pi, the radius is equals to divided by 2. So we can substitute d over 2 whole square, and you can calculate d square over 4. So you can substitute the value inside it and you can calculate the area. You will get this. So in this examples, we learn how to take the readings of vernier calipers and screw gauge. In many experiments, we are plotting the slope. We are plotting the straight line. We are plotting the straight line in many experiments. For example, in case of free or in case of the kinematics, for example, we are plotting position versus time and velocity versus time. So it gives you the slope. So for example, for this curve, the slope gives you velocity, and for this curve, so we get acceleration. The slope is acceleration. So in many cases, like free fall and circular motion, in every plot we used to have to calculate the slope. So for the slope, you select any 2 points on the plot. So this is your y, this is your x. So your slope is nothing but y2 minus y1, x2 minus x1, and you can calculate the slope whatever on this axis, and this will give you the value of experimentally we calculated. For the time period of a simple pendulum, you can calculate it like this: L over G. So this is for the experimental. You can calculate the acceleration and gravitational acceleration from the simple pendulum. And for the circular motion, Fc is mv square over r. So you plot F is equals to m over r v squared. So this is your slope in case of circular motion. So this is the time period of simple pendulum, and in circular motion. So you have this kind of experiment, and then you have many more experiment like the Newton's law. So Newton's law, so when you plot F equals to ma, and if you plot Vf versus a, so the slope will give you the mass. So in that case, so you can try this. So the main thing is to calculate the slope in these experiments if you are given the data of different type of. For example, in energy conservation, we're going to use this formula, which is the elastic potential energy of the spring, and similar kind of calculations can be done. So if you prepare yourself all the lab reports and if you know the experimental setup very well, so you can do the final exam, which is very easy and could be related to this. So no formula sheet will be given, so you need to remember these formula. For example, in case of momentum, P equals to mv. Okay, and one more thing is for the object which is freely falling, y equals to 1/2 gt squared. So I covered most of the formulas in this video and how to take the readings of vernier caliper and screw gauge. So best of luck for the final exam. Hope you have a good final exam. See you after the final exam. Goodbye. Bye bye.